In this video, we're continuing section 1.3 on exponents, and we are going to do some review of exponent rules. Okay, so let's let x, y, m, and n be real numbers. So for each of the following exponent properties, they're going to hold as long as both sides are defined. And we'll see an example in just a sec where that will end up mattering. One of the sides might not be defined, and then we got to be careful and may not be able to apply it. Okay, so I'm going to motivate each of these exponent properties with an example. Okay, so for the first one, let's say I have 7 squared times 7 cubed. Alrighty, so to do that, 7 squared means 7 times 7. Times 7 cubed is 7 times 7 times 7 3 times. So in total, well, I'm doing this 5 times. This is 7 to the 5th. So the general rule is if I have x to the m times x to the n power, we end up adding those exponents. Okay, because we have m of these x's, and then we got n of them. And so in total, we got m plus n of them now. So I'm going to highlight this. There's my general rule. Okay, so what if I do this but with a division? So 7 to the 5 divided by 7 squared. So 7 to the 5 means 7 times 7 times 7 times 7 5 times, divided by 7 times 7 twice. So here I can cancel a little bit. I can cancel 2 of these 7s on top with the 2 7s on bottom. So I'm left with still 3 7s on top, which gives me, well, 7 cubed. Okay, so what happened there? The exponents ended up getting subtracted. That's my general rule. I'll get x to the top exponent minus the bottom one. Okay, let me highlight this. There's my second exponent property. Okay, let's go to the number 3. So what if I have a power, like 7 squared, and then that whole thing is to another power. So a power to another power. So, well, 7 squared, if I cube that, means I get 7 squared times 7 squared times 7 squared 3 times. Okay, and each of those 7 squares means 7 times 7. So I got one of those, the second one of them, and then that third 7 times 7. So in total, I have, well, 6 of these 7s multiplied. So this is 7 to the 6. So the general rule there is, well, if I have a power to a power, the powers get multiplied. So over here, I'll have x to the m times n. Power to a power like this, and the powers get multiplied. Okay. All right, for property number 4. So I have 7 times 8 cubed. So let's work that out first. So 7 times 8 cubed means I'm doing 7 times 8 times another 7 times 8 times a third 7 times 8. So overall, I have 3 of these 7s multiplied and 3 of these 8s multiplied. And because I'm just doing multiplication, I can reorder them. And that'll leave me with 7 cubed. 7 cubed times 8 cubed. In other words, if I'm multiplying two things, and then I raise that whole thing to a power, I can distribute that power to each of the terms. I'm allowed to do that when I'm multiplying terms inside. Okay. All right, so in general, if I have two things multiplied to the m power, I can distribute the power to get x to the m times y to the m. Okay. So the same thing is going to be true if I'm dividing two terms. So for the division, I'm not going to give a specific example. It would be virtually identical to what I did here. I'm going to state the general rule, though. So if I have two things being divided and the whole thing to a power, I do get to distribute the power to each one. And I'll get x to the m divided by y to the m. Okay, so let me highlight this rule as well. Okay, so recall we've kind of seen these last two before in a previous video. I can distribute a power when I'm multiplying terms or dividing them. But if I scroll up a little bit, when can we not do that? We're not allowed to do that. So we're here. We're not allowed to distribute a power when I'm adding terms or subtracting terms. Then I'm not allowed to distribute that power. Okay, let's scroll it back down to where we were. Scroll it back down. Alrighty, let's do an example. Okay, so I want to note when I do this what I set up above. Both sides have to be defined if I'm going to use an exponent rule. So let's look at an example where this kind of breaks down. Let's say I had negative 2 to the 1/2 times negative 2 to the 5/2. So which exponent rule does that kind of look like out of these? Well, it kind of looks like the first one. Negative 2 to a power times negative 2 to a power. So it kind of looks like the one where I would get negative 2 and then end up adding the exponents. So adding them, we get 1/2 plus 5/2. So that would give me negative 2 to the 3, because 6 over 2, that's 3. But that's not right. So how come? Like, what's the correct way of doing this? Well, I actually want to notice that these things on the left, like a 1/2 power means a square root. So what I have is, this first term is square root of negative 2. The next term, well, the 2 on the denominator means it's the square root, so I get a square root of negative 2. But then the 5 on that numerator means that's being 5th powered. Okay, but now I have some negative numbers inside of square roots. Well, both of those are undefined. So as a result, if this was my original problem, to simplify it, well, the answer would be undefined. I would not be able to, that's why there's a not equal to sign. I cannot just add the powers like I normally would if the bases were both non-negative. Okay, because I have undefined things. If something's undefined, the whole thing is just undefined. I can't do any exponent properties to it. Okay, all right, let's flip the page. Let's do some more examples. All right, so the next one, let's simplify the expression, eliminating any negative exponents. Okay, all right, so I got 3 to the 1 minus 3 to the negative 1, and the whole thing to the negative 3 power. So I first want to do this the incorrect way. So the incorrect way is to say, so I'm going to put a not equals to here because it's not going to be right. I'm going to take this power and I'm going to distribute it to each of these terms. Okay, so if I do that, I'll get 3 to the 1, that whole thing to the negative 3 power, and then minus 3 to the negative 1, and that to the negative 3 power. Now we just kind of talked about this, but the reason why this is incorrect is I can't distribute a power over an addition or over a subtraction. And I am subtracting terms here. I can only distribute the power if these terms are being multiplied or divided. Okay, so that's incorrect. Well, then what's the correct way of doing this? Well, we've seen stuff like this before. So the correct way to do this, I'm actually going to simplify the stuff in parentheses first. So the 3 to the 1 is 3. 3 to the negative 1 is 1/3. So 3 minus 1/3, that whole thing to the negative 3. Okay, so now let's simplify the inside of the parentheses. 3 is, get a common denominator, that's 9/3 minus 1/3. So that whole thing to the negative 3 power. Okay, so now I can subtract those two fractions. I get 8/3 to the negative 3. And we've seen earlier in this section that if I have a negative power, I can rewrite that as 1 over, and then I get that quantity, 8 over 3, and make the exponent positive. So now it becomes a positive 3, but that whole fraction's in the denominator. Okay, so equals that. So now I got 1 divided by this fraction. So that's, when I divide by a fraction, I'll get that 1 multiplied by the reciprocal. So the reciprocal is 3 over 8 being cubed. Okay, so 1 times something is just the something. So now I got to work out that that fraction cubed. So when I cube it, I can distribute the power to the numerator and the denominator because I'm dividing my terms. So on the top, I'll get 3 cubed, which is 27. On the bottom, I'll have to cube the 8. I might have to think about that a little bit. But it turns out it's 512. Okay, that's my answer. It's 27 over 512. Okay, that's the correct way of doing that. All right, let's do another example, part B here. This time I got a problem with some roots. So I got cube root of negative 16 and then plus cube root of 250. All the examples we've looked at so far involving roots have involved roots that have kind of simplified kind of perfectly into whole numbers. Like, cube root of 64, that's really nice. That ends up just being 4. Because 4 cubed is 64. These cube roots don't simplify so perfectly. So how can I do these? How can I do cube roots when they don't simplify so perfectly? Okay, so I'm going to illustrate the idea with the 250, but it's going to be very similar for the negative 16. In fact, so I'm going to be doing it for the harder term, illustrating the idea. Okay, so what can I do? What I'm going to do is make something called a factor tree. So 250, what I think of is think about two numbers that multiply to 250. There's a bunch of things that work, but what's one possibility? I could do 25 times 10. Those multiply to 250. And then I keep going like this. So now I take the 25 and I think about two numbers that multiply to 25. So like 5 times 5. I want to keep splitting it up into smaller numbers like that until I reach prime numbers. Okay, so 5 is prime. I'm going to box these 5s. Those are prime. The only thing that divides a prime number is the number and 1. Okay, so 10, I can split that further. That splits up into 5 and 2. Okay, so both of those are prime as well. So that's prime and that's prime. So what that means is the number 250, it ends up being all of these prime numbers that showed up at the bottom multiplied together. So 250 is 5 times 5 times 5 times 2. Okay, so that's going to help me simplify the cube root. And let's take a look at why. So cube root of 250, so I got cube root of 250. So I got cube root, and I know 250 is 5 cubed. It's 5 cubed times 2. Okay, and I can use one of my exponent properties on this to split this up. Because I'm multiplying these two things, I can distribute that root to each of them. So I'll get cube root of 5 cubed times cube root of 2. And then with cube root of 5 cubed, well, those two things cancel. Okay, I'm allowed to do that as long as this base is a non-negative value. Okay, so I end up getting 5. And then, of course, times cube root of 2. Okay, so in other words, I was able to sort of pull a number out of that root. That's really nice. So why am I allowed to kind of do this step where I kind of distributed the root to each one of those terms? I claimed it was one of our exponent properties, but let me just kind of try to break down why a little bit more. Okay, so if I have this big cube root means a 1/3 power. So inside of the 1/3 power, I have 5 to the third times 2. And I do have an exponent property that says if I'm multiplying two things and that whole thing is being raised to a power, I can distribute that power to each term. So that'll give me 5 to the third being raised to the 1/3 times 2 being raised to the 1/3. So I can do that. And if I did this, well, now that's the same thing as writing it in this cube root form where I distributed the cube root. So that's why that's an okay thing to do, distribute roots in the same way I distribute exponents. Okay, all right. You might also notice that with this 5 to the third to the 1/3, now I could use one of my other exponent properties that says when I have a power to another power like this, I multiply the powers. So 3 times 1/3, 3 times 1/3 is 1. So that's just 5 to the 1, which is why it becomes just 5. That's another way to see why it becomes 5. Okay, so if I wanted to, I totally could do a factor tree on this cube root of 16. In fact, I would definitely encourage you to pause the video for about 1 minute to try that factor tree on your own right now. I'm just going to tell you what it ends up giving me, but I want you to pause the video and try it on your own. 4, 3, 2, 1, pause it. Try to simplify that cube root of negative 16. All right, so hopefully you did that. Hopefully you made a factor tree to try to simplify that cube root of negative 16. It might not have been enough time to finish it, and that's totally fine. I only gave you a minute, but let's talk about it. So the cube root of negative 16, it'll turn out that it ends up giving you negative 2 to the 4th. Negative 2 to the 4th. You'll get 2 times 2 times 2 times 2, 4 times. Okay, so what I'm going to do with that is I'm going to rewrite that a little bit. I'm going to rewrite that a little bit. Okay, so this will become... So with that negative 2 to the 4, I noticed that if I kind of split this up, I can leave 1, 2 isolated like it was in the other term. So I'm going to get my big ol' cube root. I'll kind of move 1, 2 to be by itself. And all the other 2's, the 2 cubed, I'll keep them together. So negative 2 cubed times the 2. Okay, now I'm going to distribute that root like I did before. So if I distribute the root, I'll end up getting cube root of, I'm going to do the second term first, cube root of 2. And then I'll end up having the first term, cube root of negative 2 cubed. Let me work that one out on the side. So if I do cube root of negative 2 cubed, well, negative 2 cubed is just negative 8. And if I cube root that, well, it ends up being negative 2. Okay, so I'll end up getting negative 2 for that first part. Okay, so now I have some like terms because this first term has a cube root of 2. This next term has a cube root of 2. So I have negative 2 cube root of 2 plus 5 cube root of 2. So that just becomes 3 cube root of 2. And that's my answer. So what did I do here in this last step? This is kind of like, so when I have like terms, it's kind of like if I had negative 2x plus 5x. Overall, if I add them, how many x's do I have? Well, I have 3 of them now, 3x. And that's what I have. I have 3 of this cube root of 2. Cube root of 2 is kind of like my x. Okay, all right, let's do another example. All right, so part A here says, well, what's square root of 123 squared? What is square root of 123 squared? So I'm really going to try to break this down in terms of what the square root means. Okay, so when I'm square rooting something, I'm asking myself, what do I square to get the number that's inside? And there's 2 things that could work here. One thing is if I put 123 in there, clearly the 2 sides are the same. But it also works if I did negative 123, because if I square the negative, it goes away and I get the same thing. But I know that from our definition of a square root, that when I get the output of a square root, it needs to be a non-negative value. So the number that I'm looking for here needs to be non-negative, and that's why it's got to be the positive number, the 123. So this is going to be 123. Okay, all right, let's look at part B here. So part B, I got a very similar looking thing. I got square root, and inside of it, I got negative 123 this time being squared. I'm going to do this in 3 ways. It'll turn out a couple of these are wrong, and I'm going to do them because I want to point out some very common mistakes that I see people make with problems like this, and they're worth just being explicit about. Okay, so first way. In this first way, this person kind of noticed that, wait, won't the square root and the exponent just kind of cancel? And won't that just leave me with negative 123? It turns out that's impossible, though, because if I square root anything, the square root of any number, no matter what's inside of it, whatever the square root is, the output needs to be non-negative, so it can't be. The answer can't be negative 123. Can't be negative 123. So because of that, whatever this person did must have been incorrect. For some reason, they aren't just allowed to cancel the square and the square root, which is a little weird. You might have thought that, wait, isn't that something we can do? There's a reason for that. It turns out we can't just cancel them when the number inside of it is negative, like what was going on here. In the previous one, it was positive, so it was okay to do the cancellation. Okay, so this first method didn't work. Let's try it another way. The second person said, okay, well, I got a power and I got a root. Doesn't that mean I can rewrite it as a fractional power? Because the power goes on the numerator of the fractional part. The root, this is a square root, that goes on the denominator of the fractional part. And if I simplify 2 over 2, that just becomes a 1. And then, well, that would just give me negative 123. Well, that can't be right for the same reason. Like, a square root can't give me a negative number as an output. Okay, so this same reasoning applies here, and it applies to this answer as well. Like, it can't be negative 123. So, okay, this has got to be incorrect. But why? Like, why can I not do that? Why am I not allowed to take a power and a root like this and rewrite it as a fractional power? I thought that was possible. So if we go back and we look at our definition from a couple pages ago, fractional powers, when we rewrote them as roots and powers like this, there's one important thing that we are kind of ignoring here. The base, the a, it's got to be greater than or equal to 0. It's got to be non-negative. But in my problem, in our example, this base here is a negative number. So because of that, we can't use fractional powers. That's why this method didn't work. Okay, so far both of these methods haven't worked. And the key reason why is because they had this negative base that prevented them from working. So then how do I do this? I kind of have to do it this more general way I approached part A. So I got to think about square root means, what do I square to get the thing that's inside of it? What do I square to get the thing that's inside of it? And I've actually made one typo here, because the thing that's inside is negative in parentheses 123 squared. So let me fix that. So what could go in this parentheses to make it work? Two things. It could either be negative 123. That's clearly going to match up. Or it could be positive 123. Because with both of these, when I end up squaring my number, it'll end up getting rid of that negative. Okay. Well, I know I have a square root. So the output, the number that I'm looking for, needs to be non-negative. So as a result, well, it's got to be the positive 123. So that's my answer again. It's positive 123 again. There's another way I could have arrived at that answer. Like I could have from the beginning been like, wait, squared and a negative? That's going to change it into a positive. And if I changed it into a positive first, well then I am in the clear to cancel them away because now I don't have a negative base anymore. Okay, but I wanted to do it this way, thinking about what a square root means in terms of thinking about what squared equals the thing inside, because it's going to help us in more general situations, like the next example. So what if I have a variable inside of my root? So what if in part A I got square root of x squared, and part A says, well, that base is greater than or equal to 0. Okay, so let's think about it in this more general way. Square root means, what do I square to get the thing that's inside? In this case, that's x to the 2. Well, there's two things that work. This could be x, or it could be negative x. Because even if I had negative x, when I square it, it would get rid of that negative sign. So I know that this original thing needs to be non-negative. It's going to output a non-negative value, and there's two reasons why. Due to the square root, whatever's in the square root, the output's got to be non-negative. There's one other reason why it's always going to output a non-negative value. It's also going to do it because, well, there's an even power. This 2. No matter what gets plugged in, if I have an even power, it's going to get rid of any negatives. So also because of the even power. So there's two reasons why this square root is always going to give me a non-negative value. Okay, so because of that, the answer that I'm looking for needs to match that. The answer that I'm looking for needs to be non-negative. Okay, so I'm given that x is greater than or equal to 0. In other words, x is non-negative. So x is a number like 2 or like 7.5. So given that, which one of these answer choices is non-negative? Well, the non-negative one, I'm going to highlight it, is the x. That is the non-negative one. That's going to be the non-negative one. Okay, so in part A, my answer is just x. It simplifies to just x. Another way I can kind of see that is, well, because my base is non-negative, I am allowed to do the cancellation between the square and the square root. Okay, let's look at part B. Part B is changing the condition, and now it's saying x is negative, x is less than 0. So I'm going to think about it in the same way. What do I square to get x to the 2? So it could either be x, or it could be negative x. Okay, just like before, this square root, whatever I get out of it as the output, needs to be non-negative due to two reasons. Due to the fact, well, there's a square root, so the output's got to be non-negative. And because of the even power. So two reasons why, no matter what I plug in for the x, the thing I'm going to get out is a non-negative value. Okay, but this time it's a little different. Now x is a negative number. X is something like -4 or -11. Okay, so if x is a negative number, which of these answer choices is non-negative? Well, it's the negative x. Whoops, I'm going to switch to the pen mode. Okay, so the negative x, that is non-negative. So x is a negative number, which means this other negative in front of it changes it into a non-negative. Okay, so in this situation, part B, the answer is -x. Okay, a little weird, but that's happening because of this condition here, the fact that x is negative. X being negative makes this other negative in front change it into a positive. Okay, finally, part C. What if there's no condition? What if it's just square root of x squared and there's no condition given? Okay, so again, let's think about it in the same way. What squared equals x to the 2? So it could be x, or it could be -x. Okay, just like before, no matter what gets plugged in for the x, this whole output is going to be non-negative. Non-negative due to the square root. The output of any square root's got to be non-negative, and due to the fact that there's an even power. The two reasons why this output is going to be non-negative. Okay, so I'm looking for an answer choice that is always non-negative. Except this time I don't have a condition like x is negative or like x is non-negative like before. So sometimes, so if I think about these two answer choices, if I think about this first answer choice, could that be negative sometimes? Yeah. Like if I let x be a number like -3, that answer choice is going to be negative. So this one definitely could be negative sometimes. So that's a bummer. It's not always non-negative like I need. Could the other answer choice be negative sometimes? Yeah, if I plugged in like a number like x equals +4. If I plug that in, I would get -4. And that's negative. And I don't want that. I want my answer to always be non-negative. So the problem I'm running into here is, well, neither answer is always non-negative. Okay, so there's two ways to kind of get around this. For the time being, let me just say that the square root of x squared equals the answer choice x. I know that's not always right because there's stuff I can plug into the x that makes it negative, like -3. But if I plug it into this one, it won't be. Like if I plug in -3 here, the square is going to turn it into a positive, and that makes them different. Okay, but if I were to plug in positive numbers into both of them, they're fine. They're going to be equal. So what I need is, I need to do something to this answer that, like right now, if I plug in a positive number, it's good. I need it to stay the same. But if I plug in a negative value into this, I need it to switch its sign so that it matches the sign of the other side. So there's a thing in math that does that. If a number's non-negative, it leaves it as it is. But if it's negative, the sign gets switched. And the thing that fixes it is an absolute value. I need an absolute value in my answer to guarantee that my answer is always non-negative. So because neither answer was always non-negative, we need an absolute value to guarantee a non-negative output. There's one other way I could have written this answer, so I also want to talk about that. Create a little separate space for this. The other way is to think about these answer choices and instead create a piecewise function, because sometimes it's one of the answer choices, sometimes it's the other. So square root of x squared, well, sometimes it simplifies to the answer choice x, so I'll think about when that happens. Sometimes it becomes the answer choice -x, and I'll think about when that happens. So when is it going to be the first answer choice? Well, I need to know when that thing is non-negative. So when is that non-negative? That happens when x is greater than or equal to 0. When would it be this other answer choice? Well, it becomes the other answer choice in this condition, when x is negative, when my base is negative. So that's the other way I could simplify square root of x squared. I could use a piecewise function. Typically in our class, like almost all the time, I'm going to be using this absolute value form though, because it's just more concise.